When we look up at the sky, we tend to see an open, boundless space, a symbol of ultimate freedom. But that appearance, as it turns out, is quite deceiving. In reality, the airspace above us is one of the most structured, regulated, and meticulously managed environments on Earth, all governed by a complex set of invisible rules that ensure the safety of every single flight.
At the heart of this entire system are foundational documents that guide the actions of every person involved in aviation. From the pilots and air traffic controllers to airport administrators, all operations are conducted under the authority of these core texts. This ensures there's a common language and a universal standard of safety, which is really the bedrock upon which the global aviation system is built.
So, to understand how this system operates, we'll begin our journey from code to cockpit by examining the foundational text for flight operations here in the United States, the Aeronautical Information Manual. Now, there's a crucial distinction to make right away. While the Aeronautical Information Manual, or AIM, is not technically law itself, it functions as the FAA's authoritative guide. You can think of it as the official operational manual, translating complex regulations into practical procedures that pilots follow for everything from pre-flight checks to landing.
The scope of the AIM is truly immense. It covers everything from the physics of navigation to the medical fitness of a pilot. This isn't just a simple list of rules. It's a complete ecosystem of knowledge, designed to account for every possible variable that could impact the safety of a flight, and it's all built upon decades of experience and learning.
All right, let's transition from the rulebook to the physical infrastructure that makes these rules work. We'll now explore the ground-based systems that create what are essentially invisible highways in the sky, allowing pilots to navigate with precision even with zero visibility outside the cockpit.
The most effective way to think about these systems, which are known as navigation aids or navaids, is to picture them as lighthouses, but instead of emitting light, they emit radio signals. These signals provide constant, reliable points of reference that allow an aircraft to determine its exact position and follow a designated path. One of the earliest and most fundamental types of navigaids is the non-directional radio beacon, or NDB. It's a simple but very robust technology. The NDB transmits a signal uniformly in all directions, and an instrument in the cockpit simply points toward that station, giving the pilot a clear and constant bearing.
This table illustrates the remarkable level of detail within the AIM. The manual provides precise operational data for every piece of equipment in the system. As you can see, the reliable range of these NDB lighthouses is clearly defined by their power and their class. This isn't trivia, it's critical information that ensures a pilot knows with certainty which navigational aids they can trust at any given moment.
As an aircraft nears its destination, the need for precision increases exponentially. This is the role of the Instrument Landing System, or ILS. It is a highly sophisticated system that provides exacting guidance, both left to right and up and down, guiding a plane perfectly onto the center line of a runway, even in weather where the pilots cannot see it at all.
The ILS guides the aircraft through the clouds, but in the final, critical moments of flight, the pilot must transition from instruments to visual cues. At this stage, the sky begins to speak in a universal language of light.
These systems of lights, known as visual glide slope indicators, are a crucial safety tool. They provide immediate, intuitive feedback, allowing pilots to visually confirm that their aircraft is following the proper descent angle for a safe landing, one that is clear of any obstacles.
The most common system is the Precision Approach Path Indicator, or PAPI. It communicates through a simple yet absolutely critical color code. 2 white, 2 red means the aircraft is perfectly on the glide path. This elegant system provides instant, unambiguous information right when it matters most.
Now, this reveals one of the most surprising details in the entire system. At thousands of smaller airports that don't have a 24-hour control tower, it's actually the pilots who turn on the runway lights themselves. By clicking their radio microphone a specific number of times, they can activate and even adjust the intensity of the entire airport lighting system right from the air.
So we have the rules and the ground-based infrastructure. Now, let's zoom out. We'll see how these elements combine to organize the entire sky into a coherent operating system for managing traffic flow.
The sky is primarily divided into 2 categories: controlled and uncontrolled airspace. You can think of it as a difference between a major highway system, which is managed by air traffic control, and a rural country road, where pilots are responsible for their own separation. Each has a very different set of rules and requirements. This table provides a concrete example of how those rules change based on the airspace. For a pilot flying by sight, under what are known as visual flight rules, the minimum weather conditions are different depending on location. For instance, in the dense Class B airspace around a major airport, a pilot must remain completely clear of clouds. The traffic is simply too fast and dense for anything less. In other, less congested areas, specific distances are mandated to ensure safe separation and reaction time.
We have explored the rules, the navigation systems, and the structure of the sky. Now we'll bring these elements together and focus on the final and most crucial component of the safety system, the human operator who must interpret and navigate it all.
So the crucial point is this. Before any flight, the pilot in command has the ultimate responsibility. They must meticulously gather and review all available information, from weather reports and temporary airport closures to the currency of their charts. The system provides the data, but it is the pilot who makes the final judgment, acting as the final link in the chain of safety.
Ultimately, the Aeronautical Information Manual reveals a hidden world of order and procedure. It demonstrates that the freedom we perceive in the open sky is only made possible by an intricate, invisible system of rules and cooperation. And this makes one wonder, what other complex systems are quietly guiding our world, working perfectly in the background of our daily lives?